There we go. All right, time to start.
Time to start.
So welcome. I'm not quite sure how many annual software or Doctoral Fellow symposiums we've done, but it's been a number of years now that we've sponsored this in conjunction with our annual research review, welcoming both the fellows that are officially doctoral fellows in the SERC, as well as a number of other PhD students who are doing work across all of our SERC projects. So, so welcome everybody. We go through a competitive selection process. So I think out of the briefings today, we probably took about a third of the requests to present the PhD work going on. For you, those of you who are presenting, we do out of the day pick a best presentation award for the best doctoral fellows research that has a monetary prize associated with it. So that's a good thing. We won't be announcing that at the end of the day because we'll be needing to go back and review, but we'll announce it within the next week who the winner of that is. And just if you weren't at the research review, this is the first year that is the Dr. Barry Bain Best Student Research Award. So we were very pleased to be able to name it after Barry this year. So thank him for his many years in association with the SERC and his family
and his students. So
yeah, so we'll go ahead and jump into our program. Kara, you can introduce.
Sure. So our first presenter is Miss Stephanie Chiesi. She is a SERC fellow, and she's currently a principal aerospace systems engineer with advanced development programs at Blue Origin. She holds a BS in aeronautics and astronautics, a BS in biology, and a master's in aeronautic and astronautics from MIT. She's a doctoral candidate at Stevens Institute of Technology in the School of Systems and Enterprises under the advisement of Dr. Paul Grogan. In her current position at Blue Origin, she is the digital thread lead for Orbital Reef. Stephanie, over to you.
Thank you all. Can you hear me just fine?
We can.
Great. I'm doing the best I could with the bandwidth check, but it looked like it was just fine. So thank you. I'm excited to kick this off today. And great, huge thanks as always to my advisor, Dr. Paul Grogan at Stevens. He is definitely somebody who has given such great insight to my thoughts that I'm bringing to the research as somebody who has been in industry for just about 20 years now. So I live and breathe an awful lot of the problems that certainly SERC seeks to do research on. And some of that gap is certainly an area where I look to bridge. So today I'm going to talk about some insights on digital engineering impact on design cycle time with the Lyneis Rework cycle. This is something I was very excited to hear cycle time brought up as a key factor by Kristen Baldwin in our keynote yesterday afternoon at the sponsored research review. So I'll just go through a little bit of my motivation, the digital engineering implementations that we're seeing in industry right now that address cycle time. And I'll introduce the Lyneis Rework cycle and talk about how would digital engineering implementations impact that, as well as talk about future work. So the motivation that I've certainly had throughout my research career, as well as a significant amount of my practitioner career, has been based on the digital engineering strategy published in 2018 with updates that have occurred since then, such as the guideline published in 2020 and a number of other evolutions of the strategy, like the digital engineering measurement framework, digital engineering competency framework, and so many other great products. The focus of this has been to modernize the design, development, operation, and sustainment, and transform the acquisition and implementation of technology for the warfighter. And I'm highlighting that improving that speed for critical capability delivery is certainly an emphasis of the strategy. And it's the area that I've certainly driven my research to. It's the focus that I think is the desired outcome. It's the desired goal that we want to achieve with the digital engineering strategy. So when we think about what are we doing in digital engineering to address that cycle time, to reduce it, to improve that speed, a lot of the emphasis on digital engineering implementations right now is on integrating tools and data exchange so that we can remove air gaps or other gaps between individuals, between tools, between domains, the different silos that have occurred. We're looking at implementations that automate tasks that don't necessarily involve human decision makers. And we're looking at ways that we reduce those human entry errors as well. When I think about the different types of areas that are brought up as the case studies or examples, and we think about different programs or different events that have occurred in aerospace and defense, it's usually tasks that are assigned with, well, I didn't necessarily have the right data available, or there was an entry when I took it from this spreadsheet and input it into this different tool. These are a lot of the tactical implementations that digital engineering is seeking to address. But now when we're talking about it in terms of cycle time, we do need to understand what cycle are we talking about? Where is it that we are looking at cycles and cycle time? And so the images that I have here are looking at what I definitely am somebody who's a fan of taking our engineering V model and looking at it at that diamond understanding as we're looking at the physical systems and the digital systems. We're looking at our digital twin and our digital thread, and we're looking where that knowledge is gained across the entire development life cycle, both from what we can do in simulation and in a virtual world, as well as how it's partnered with what we're doing in the real build in different technologies that we certainly have for doing rapid prototyping and rapid development, and how that all helps build towards that delivered system. Now that type of life cycle is also different than when we talk about the Department of Defense life cycle, when I'm thinking of the different milestones that we have to pass for contract award and how we work with industry, since I'm so typically on the industry trying to win the different contracts at those milestones. It's definitely different information, different decision making, and different types of cycle time that we're talking about between the two. And so this is something that I've brought out in my research, that we need to look at what that evaluation is. What are we doing for cycle time, and how do we actually evaluate success? So what do we call success at reducing cycle time? Now, within the design cycles, within the type of work that is done in industry, utilizing the engineering V or diamond model, this is where a lot of the implementation focus is right now, in terms of looking at those automated tasks, looking at how we can reduce human touch time and those entry errors. But largely those tasks are not addressing or replacing human decision making. We're connecting the data, we're making it available. We're talking about how that speeds up different parts of the process, and whether we know or not, that's part of what I'll talk to. But we're not changing, we're not talking about how it's going to make a human decision-making step go faster. That's when we look at the other part of the cycle time that I referred to, looking at when we have our decision-making going on in our life cycle progression. This is where we have that human involvement, and it's not a single decision maker, it's a different body of decision makers, whether it is a customer supplier relationship and it's customer accepting and signing off on passing a critical milestone review, or a decision being made on a contract award. Plenty of times either or both sides have independent subject matter experts, whether it's from national labs or FFRDC's type involvement. There's a lot of information, a lot of different decision-making processes that go on in this. These are largely using outputs of digital engineering, of our design cycles for the decision-making. But often these are decisions that I'm talking about where the teams and the individuals making those decisions were not necessarily the ones producing the digital engineering or working in the digital engineering environment. So this is where we're talking about the milestone phase of the work. So for today's talk, I'm going to focus on how we could look at the within design cycle time. And this is looking at how do some of these digital engineering implementations, how can we qualitatively start to look at what that means for cycle time and what we need to be cognizant of as we're continuing to develop these techniques, if it's getting the desired impact on cycle time that we want, or if we need to maybe shift more of our focus into some of the areas on the other type of life cycle time that I've got on the side here, or look at more what some of these other feedback and future impacts are of the implementations we're trying to do now. So let me introduce the rework cycle. The rework cycle was produced by Dr. James Lyneis at MIT as a systems dynamics model that was utilized for project management. I really liked learning about the system dynamics model for this. It's very cool to translate the different theories that we have into equations that are representative of these social and physical systems. Engineering design cycles, I think, aligns really well to this, and especially to utilizing this studied and already documented model as a surrogate for how we can understand and look at our life cycle time within design cycles. We've got descriptions of the different processes and interactions that have been converted to stock and flow equations. There is a potential for doing simulation of this so that you can understand the different impacts of change. And it also enables us to look at direct and indirect impacts, as we can look to add feedback loops and both reinforcing or negative feedback loops to understand where certain properties of our overall design cycle and the system that we're operating in might actually have greater impact than we realized as we're going through this. Let me get my, okay, good. Mouse did not freeze. I hope, just quick check, I see something on my screen. Is that something I need to close out?
Nope, you're good.
Okay, good. Okay, so let's look at how digital engineering impacts the time to complete the rework cycle, how we can start to evaluate this. When we look at the basic rework cycle, the original work to do is representing the different tasks that have been defined for the project. And it's based on the understanding of the project scope. It can correspond to the idea of the program size, but it gives you an idea of how much work there is to be done on a given project, which is why I say this aligns very well to our design cycles, the type of work that are in our, whether it's Microsoft Project or whatever your project planning method is. It could be your Agile backlog as well. The work done is then the result of the work that's accomplished. So how do we accomplish work? It's a product of the productivity and the staff. We can define productivity and staff as the staff, that's the number of people who are available to do the work. And productivity, define it based on the units you're using for however you're capturing work. It could be a task over a given certain time period per person, certain man months, etc., whatever that metric is that's used at your location. We then also have to figure in this factor for quality. This is that a fraction of the work that's accomplished is going to have some sort of error. If there's going to generate some unexpected rework to accomplish the task, because this is something that needs to go back and be fixed. That quality is a number that'll range from 0 to 1, where 0 means you did nothing right. You have to do 100% rework. And 1 is perfect. Every task was done completely right as soon as the first time it was attempted. And so the greater the quality that you have, the fewer errors that you have. What does that help as far as this cycle goes? Well, that influences the undiscovered rework. So undiscovered rework is the product of the work that is accomplished times 1 minus the quality. So here's our inverse. It's sometimes also known as the rework generation, but the result here is the how much work do you have to do that wasn't part of your original plan? What was your plan for knowing that you'd have to address some errors or some rework? Then we have another flow, which is rework discovery. This is the undiscovered rework divided by the time to discover rework. And so this can range from 1 to very large, where 1 would represent immediate recognition of undiscovered task. And as you get to infinity, it would indicate never recognizing the undiscovered work to be done. So how can digital engineering impact this? How can we look at digital engineering in the rework cycle? So one way when we look at the digital engineering implementations now The automation that we're talking about could reduce the human delivery time for the tasks. This is a way of influencing and increasing productivity. So one potential here for looking at this impact is looking at a range of the factors to see how digital engineering automation can increase this productivity and what that overall impact is on the cycle time for this representing design cycles. Another place is that digital engineering automation could decrease the staff required to complete tasks. This is certainly something where it's been that has been suggested by a number of the different implementations that have been put forward in terms of not having to wait for others to complete work and not having to have others in line if there are people who are capable of doing multiple of the different tasks. Having some of the other automation can free up more people so that there's actually less total staff needed, depending on skill set fit, of course. But again, this is another way of evaluating a range to see if staffing can be reduced. What is that impact on our total design cycles? Next, we can look at how digital engineering implements automated error checking. This is something that should ideally increase quality and reduce the undiscovered rework stock. One of the features that I know is heavily utilized in a digital engineering model-based system engineering profile that is publicly available by one of my former employers, SAIC, is to have a validation suite that is built into their model to automate that error checking process and ensure that tasks are completed correct or as correct as possible as part of the design cycle. Again, this is targeting having a high quality amount for the design cycle time and completion of tasks. Finally, another part of the digital engineering implementations that we look at, especially as we're looking at digital thread and the connection of the different tools and data elements, is implementing automated notifications. The awareness of changes that are made in the overall system during the design cycle helps different discipline experts, different domains, understand the impact to their given area of expertise or design or analysis. And it's reducing that time to discover rework through this automation of alerts. The we don't know what we don't know phase is best suited by this when at least a notification or some sort of way of flagging that something has changed that affects your part of the design, and it helps notify that rework to do much quicker so that at least the knowledge and ability to address those tasks can be brought. Now, while these are great ways that our implementations have already been thinking of addressing this, what we now need to look at is how does digital engineering, though, impact these potential feedback loops that can occur and be reinforcing or negatively enforcing some of our cycle time. Okay. So as I just talked about the idea of increasing an automated notification of changes or errors, that definitely helps present monitoring and forecasting in different targets to indicate known work is remaining. But that known work is remaining is indicating, okay, well, now I need to look at, do I need more effort applied in my system because my deadline hasn't moved, so my time remaining has decreased, but I still need to make sure that I'm still getting the tasks done, except now I'm aware that there's more work to do than I had planned for. So that means I had to look at, okay, how do we apply more effort? Okay, I need to either maybe increase my productivity, increase my staff. How do I achieve that? Okay, so if I'm looking at applying more effort, then it's this question of, is my hiring needing to increase so that I can have that workforce for the staff? Or am I looking at overtime for my existing staff, or just increasing certain work intensity that we're changing our processes, we're changing the way that we work in order to address this? Okay, well, what's the reinforcing loops on this? There could be some negative feedback loops that are brought into this. As you're adding people, it takes time to get those people brought into the program. So the same staff that was already contributing to your productivity is actually reducing their productivity because they need to onboard other people that are meant to increase the productivity. The same way is that you can reach fatigue or burnout when you're working more, doing these overtime, or reach slack off points when you're trying to increase the work intensity that can actually result in making a little bit less progress. The reason that it might make less progress also, maybe we're making more mistakes. Certainly if we've been working a 10 or 12-hour day as opposed to an 8 or 9-hour day, there may be times that we're not noticing, maybe we're not running a certain validation request, we're not double checking something, or we've missed pushing the next publication. So that fraction correct is not necessarily making up for however much we thought we had increased our quality. And now we're also looking at the experience of the peoples and the individuals that we've been hiring. If we've had a hit to productivity, like I said, for increasing our workforce for interviews or other hiring, well, now we have to do it as part of training for getting people onboarded to programs or onboarding to different tool sets. And again, all of that can mean that now we have unknown errors in our previous work. Maybe we've actually been led to having such fatigue in this part of the process that any gains we might have made, we might have lost. So when we look at the full qualitative model of the Lyneis Rework cycle, it can be quite complicated. There are a significant amount of previously maybe not considered as important or as impactful on the rework cycle as they can be, depending on different management and engineering responses to what they're seeing in place. So what are the next steps for the impact of digital engineering using the rework cycle? As I mentioned, looking at a sensitivity analysis of the expected impacts of these different implementations can really help us to understand where the expected benefits have the greatest impact and see what changes could be occurring due to some of these feedback loops, including there may be additional new causal loops that are created by digital engineering or maybe are really helped as opposed to as negative loop feedback heavy as I showed, that can be occurring because of digital engineering. And one thing I think is quite interesting is to look at how this study could reinforce or bring new discussion to the digital engineering measurement framework. Certainly some of the tactics that I mentioned in measuring here fit with some of the suggestions that are already there, but maybe there are some additions that could be made as well that could give more insight to actually managing digital engineering to understand the impact on design cycle time. And then finally, the future work for digital engineering impact on cycle time. My future research is looking at how we're talking and representing that human decision-making involvement, because it's a potential that the human decision makers and how they're using digital engineering and the data provided by digital engineering could have a greater overall impact on the capability delivery time. These are decisions that are definitely influencing those milestone ABC type reviews and decisions that are made that are continuing funding, continuing budgets, and then delivering to the warfighter. So these are human decision-making efforts that we need to study. So I'm looking to study this behavior using agent-based modeling and a different type of surrogate model that is used to represent the decision-making behaviors and evaluate how potential changes due to digital engineering implementation and the digital engineering environment can change those and how we can impact that on cycle time. What I like to say this is akin to is the idea of using this approach to build a basic strategy for how we should implement digital engineering and what we need to be cognizant of in order to receive the determined expected value. The image I've got there, which I have here with me, is a basic strategy for blackjack card. This is a card that represents exactly why I won't play blackjack with my husband at a casino, because he won't follow this. This is a strategy that is built to maximize the expected value of your outcome, but it also has very certain specific assumptions on the number of decks, where the cut card is on the deck. Are you counting cards? What's the shuffle rate? How many people are at the table? Are there people who go with their gut and don't follow this, and you can't trust that the cards are going to actually follow along to this? Those are the same kinds of questions that we should have about the decisions we're making in trying to increase the cycle time for what we're trying to do for the warfighter. And so that's where I'm looking to take my research next. Any questions? think I left time for questions.
I have a question.
You did.
Great.
I have maybe two questions, Stephanie.
Okay, great.
So the first question in your model,
Mhm.
um,
So I can go back to it.
Mhm.
yeah. So you didn't represent in your model this notion of scheduling the work to be done in this cycle versus deferring it to the next cycle. Have you thought about that?
I have to some degree, but part of this was also trying to scope it within a certain amount of a system dynamics problem. That is something that is, that was one of the objectives I was trying to look at, but I was also trying to scale the problem. And so then what it also can become is, well, what you're really doing when you're talking about doing the scheduling in a different cycle is a repetition of this same problem, which is part of the reason why I didn't look back at a reschedule to later, because what I was trying to do, at least with the Lyneis rework cycle here, was time box it to one certain phase. So the idea of, well, it's going to go in the backlog for a future iteration or something like that, that would just then be a new dynamics problem for the next set with similar feedback loops that way. So that's where I decided to try and cut that feedback loop, if you will.
Okay. So I think one of the things we discovered in the DE measurement framework was that what you're really trying to do is contain to the current cycle. I mean, that's where your most benefit comes from. So at some point in time, you might want to at least address that with understanding in your model as a decision factor.
Correct. And that's part of the reason why the agent-based model is what I'm looking at to do that, because the decision that's a human-based decision, not an automated decision, to move that to that cycle. Although I could look at to see how that could be something otherwise represented.
Okay. And the other thing on your decision model, on your agent-based model, I'll just point to you. Are you familiar with the Essence framework for software?
I don't think I have that one. So I would love to, if you have a reference for that, that would be wonderful.
Okay. So that Essence framework tries to help you understand how you make these decisions across a life cycle to do work or not. And they, in practice, they gamify it.
Okay.
You know, so
Yep.
it's laid out as a set of playing cards that the team uses in order to decide this rework goes in this phase versus that phase, those other kind of things like that, or how much effort do I need to apply. So we can send references to that, but it's easy to find. Essence model
Okay.
for.
Gotcha. Thank you.
All right.
I think there's a chat.
Oh,
Oh,
there's a question in the chat. Are you able to read it, Stephanie?
yes. Let's see, from Ryan, right? How about reducing the amount of rework, attacking the rework generation step? I think one of the big benefits of digital engineering is reducing the likelihood of, say, requirement problems propagating downstream to manifest in design or test. Absolutely. And I think that is I think that does part of what reduces the amount of rework is that quality factor, because you only have rework if you don't have perfect quality. So yes, I think reducing the amount of rework is part of the digital engineering implementation around quality. And while I only highlighted automated error checking, you're totally correct, Ryan, that I think the idea of understanding the stakeholder needs, or understanding and having better requirements, is a part of that quality as well.
Thanks, Stephanie.
Absolutely.
All right. With that, we will move on to our second presenter.